Good evening, everyone. Welcome back to the Astro Imaging channel. We've got another great show for you tonight. Christian Sasse is here, and he's going to talk about StarPx, which is a new platform for processing Astro images, which is launching in a few days here. Before we went live, we were just talking about the fact that we just crossed the threshold of 2 million views on our videos. That's a pretty big milestone for a little channel like us. And we are getting close to 20,000 subscribers. So it would be nice to hit that milestone as well. So, and if you're watching this then, if you certainly like the video, but if you hit the subscribe button as well, that would definitely help us out too. So before we turn to tonight's presentation, I will just quickly show the upcoming calendar here. Let me share that. So as you can see tonight, as I mentioned, Christian Sasse, and then next week we've got Bray Falls joining us. He's going to talk about the Starfront Remote Observatory, which has been online now for, I don't know if it's been quite a year, but they've been going gangbusters ever since they opened up. I know they've got, I don't even know how many buildings they have down there now, but it's a pretty big operation. So he's going to be here to talk about that. And then the week after that, Jim Thompson will be with us to talk some more about solar imaging, which I know has been a real popular subject these days that we're all pretty interested in. So the week after that, no show, it's NEAF and NEAC. And then as you can see, we do have some open dates. So as always, we're always looking for new presenters. So if you've got something that you've thought about maybe talking about, want to come on the show, we'd love to have you. So you can just fill out the contact form and we'll get in touch with you about that. So because we do have some open dates. Let's see. All right, let me stop that. All right, so that brings us to tonight's presentation by Christian Sasse. And I think we can all agree that astrophotography is a very challenging hobby. To start, we're trying to photograph very dim objects that are thousands of light years away. And then there's all the equipment-related challenges, things like mounts and cameras and filters and guiders, et cetera, et cetera. And then, of course, there's all the software that we need to know how to work, to run all that stuff. Once we get through all those technical difficulties, and then we have our data, well, now we have to process it. And, of course, that brings a whole new set of challenges and another steep learning curve. So that's where an application like StarPx comes in to help with that final step, turning that raw data into something that we can show to other people. So with that, I'll get out of the way, and Christian, well, I'll let you tell us all about the new platform that you got, StarPx.
Thank you very much, Patrick. That was a wonderful introduction. I think you should give the talk. It's just, you said it all, really great. And thank you everyone here at the Astro Imaging channel. It's really nice to be here. So my name is Christian Sasse. I'm here presenting from Vancouver in Canada. And what I really enjoy about astrophotography, it unites people all over the world. And you know, you can see that. I just heard someone even from Ecuador, from Australia. And I'm sure many of the viewers come from all over. So welcome to everyone. And thanks for giving me the opportunity. So I'm going to share my screen now. Let's get this done. And oops, let's see if that works. Okay. Can you see my screen?
Yes.
Okay. Okay, so as Patrick already mentioned, this is very interesting. So we are seeing in recent years, we're actually seeing quite a change in astrophotography. I mean, astrophotography, as you all know, is quite a tradition. A lot of the hardware and software is ASCII based and so on, comes from the early 2000s, and not much has changed. And it's still quite a lot of pain, unfortunately, to set up your telescope. Once you've done that, there's still the other part of image processing, and many people that I've been teaching on astrophotography, so were a little bit shocked because they were under the hope that it's similar to when you go to the Grand Canyon, take a picture, and then you just let your creativity go and you just work on the image. But that's not the case at all. This is the approach that we know nowadays. So the classical approach, or I can say it's the current approach really, is the first thing you do is review your data. Because as Patrick already mentioned, we have to do with very little photons, so the noise is very high. We review our data, kick out anything that has bad tracking and so on. Then comes the painful job of calibrating, as you know, darks, flats, and bias. And once we've done that, we kick it into whatever software we prefer, and that's fine. We all have our preferred software. And that does stacking. Stacking is a very common tool. It's very well known. There's open access data for that. So we stack all the data to increase the signal to noise ratio, really. And there goes more into it than just stacking. We have to plate solve. And those of you who run telescopes will know that even plate solving is tedious. It's often what we call a blind solve is not so easy. It takes a long time. Either we have to call another website or we have to put in special parameters. We have to fine tune our instrumentation. And that's not the only thing. Once we've done that, we have to fine tune the software again. Then we combine the image. We have to tell the software which is usually the red, green, and blue channel. We get some color. Then we neutralize the background. We remove gradients. We do what we call photometric color calibration. Then comes a very individual process where we remove noise, we sharpen, and we stretch. And when we've done all that, and usually we have to babysit the software quite a lot, we can finally get to the stage where we can be creative. And that's the part where the Grand Canyon comes in. So we are now at the stage where we can really fine tune the nebula, whatever you want to, and you season the image. So it's a long, long process before we can get there. And what I found actually is in the many years I've been teaching many softwares, and they're all good, they're very useful in fact, is a lot of people just give up. That has to do with the updates we have to do. You have to be quite a tech geek, unfortunately, to be able to master all this. So why then something new? And the issue is really we are drowning in sliders and complex settings, and many hours vanish in image processing. Yeah, we've all been there. We know what this is all about, right? So the question is, can you start from scratch and just with a clean slate of paper, be creative and create a type of cosmic wizard that does all that without taking the creativity away? And that's what we did. We just sat down and started writing on a piece of paper what would actually be a software, what would a software look like that would be much more amenable to also people who don't want to be tech geeks, but just want to enjoy a telescope, right? So we came up with this concept which we call drag, drop, and create. So you have a folder full of telescope images, and you just throw it in somewhere, right? And then we said, what does this software have to be able to do? Well, first of all, there are many different formats, right? We know that it's not only FITS formats, you have all the industrial standard photo formats, depending on what camera you're using, right? The next problem is you usually have to put in plate solving parameters. So we need something that's robust. We have to write our own algorithms here to be able to really solve this blind and super fast, irrespective of any headers, irrespective of any information whatsoever. That's important. And then now comes the key thing, and we're the first ones to say that. The cameras have actually become so good, and also the gradient removal tools have become so good that calibration in most cases, if not all, is completely superfluous. Now, calibration is still necessary if you're going to do photometric, for photometry and so on. So if you're measuring asteroids and so on, we're not saying you shouldn't replace it. However, we mustn't forget, in astrophotography, we're dealing with an art. We're not dealing with the science. So having said that, we're all fine-tuning images, so the calibration isn't really necessary. So let's strike that away. Now comes a very important thing, and that's called filter detection. If you actually look at a lot of these FITS headers, you'll find out there's so much wrong information in there. Not only does everybody have their own type of um, nomenclature for filters, take an hydrogen alpha filter, for example. Some use it HA. Some will say it's HA5 for 5 nanometer bandwidth. Some will call it hydrogen. The other will call it alpha. The other one will call it whatever, right? And it's a jungle. And that's also why conventional software has such problems. And you have to sit there and tell it what type of filter it actually is. So we said we need to invent a type of algorithm that no matter what, detects what type of filter you have, so that takes all the pain away. Robust stacking is mostly solved nowadays. That's easy. Photometric color calibration is also solved. Removing light gradients is also through the introduction of AI, solved quite a lot. So yes, that can be done. And then gets the interesting part. Russell Croman was the first one that I'm aware of who really did a great job here with the star removal from the object, separating the star mask beautifully, and then doing object enhancement. And since then, it's developed quite a lot. So we also tackled that part, and then you end up with a beautiful result, and then you can focus on the creativity. So that's quite a tall order that got us really involved quite into very deep maths, actually. So but we went further than that. We said, well, if there's going to be a game changer, we have to go much further. You don't actually want any expensive hardware either, because all the software that we have nowadays is coupled to some form of quite expensive hardware, and that again is operating system, whether it's Linux, Windows, or Mac. It's very much fixed to that again. So you need a state-of-the-art PC. So let's knock that away too. And then you have the painful updates with software, which you have to update all the dependencies too, and that is also very difficult. Instead, what we want is an affordable subscription. So something that you can run from any browser really is very affordable for everyone. And so we said, well, let's do a browser interface. We recommend Chrome in our case. Mostly the others should also work. And it should be cloud-based, and that's quite tricky. It should be super robust, and everything should happen in the cloud and so be solved there. And that has a big advantage, because when you have a library, when you have an update, you would in normal software have to go and rerun all your processes through the updates again. We said no. So if the person has a library, it should auto update everything. So there should just be a regenerate as soon as we have, and it should regenerate the whole library with the new features. So those are quite a few changes that we thought of. Yes, and then there comes a real major thing, and that's what we call an API. Many of you will know what an API is. An API is an application programmable interface. That gives software a huge advantage because it's a type of protocol that talks to other softwares. And we have taken a lot of care in providing what you call an API integration, so that StarPx can talk to other software, for example, Dropbox and Nina and many other things. And we have comprehensive documentation. So we are also very much hoping that the users that like our software will encourage other third parties to integrate our API in there, so that can be combined, and that makes it much stronger. Nina is a very interesting thing. We thought about Nina. I mean, I'm sure most of you have used Nina or maybe Voyager or other software, whatever you must be, Sequence Generator Pro and so on. So there are a lot of different softwares here, but the most common open source software is definitely Nina, right? So we have a version, we're working on a version, and that is going to be shortly released. It's API driven, and it will instantaneously plate solve and also do stacking. So that the idea is that whatever you take in your camera and your telescope system at night and that evening is straight away going into StarPx, loaded into the cloud, and is instantaneously processed, right? We'll take a bit longer for the live stacking that's coming, but the instantaneous plate solve should be available, hopefully much faster than the plate solve that you see nowadays. And also, we're not limiting this. We're not limiting the amount of captures that you have for any plan. So because because the images usually, and unless you're doing video or so, are coming probably at 20 or 30-second intervals, depending on what type of capture rate you have for single images, this should be very compatible. One thing we do require usually is fast internet, and that's what we hope you have, because you have to upload your pictures to the cloud. However, having said that, with Nina, not even that is necessary, because usually 20 to 30 seconds upload rate per image is even enough when you're outside. Right. So that's the basics of what's where StarPx comes in so unique. We're addressing broadband, narrowband, all the filters, fully automatic. As I said, star removal, image enhancing tools, Nina integration. Dropbox is a big thing. So if you have a Dropbox account, you can use that same API key to link your Dropbox account. That's a big advantage because you're not dependent on our storage. If you want to store your own things in your own Dropbox account, you can do that. Citizen science is another thing. We're very much into education. So citizen science will work very nicely with Dropbox because you can actually share a common folder with many others. And that way, you actually have the possibility to share your experiences and also your science, right? And then we're also developing a smartphone app. So we've already done it for both Android and iPhone so that you can have all your pictures, you can show it to your friends or so. You will also have the same abilities as a viewer on your smartphone, right? And you also have the possibility, and that's where it gets really interesting, because it's cloud-based, it works insanely fast and thorough. There's an object search that will go through your whole library. So if you type in specific, specific designations from catalogs like TAIC and well, NGC's, most of Messier and so on, the ones that I've listed there, they are searchable. So it will identify those, stars or objects in your in all your images and will identify where they are, right? So that's the key thing. Just a very quick thing about cloud infrastructure. That's quite difficult, actually. I think that's probably also why this hadn't been done before. Cloud infrastructure is developing at a rapid rate, but it's a jungle. I can promise you it's very difficult, because in order to make such a tool work quietly in the background, you are developing so-called instances, especially with the GPUs and CPU allocation. So that's where our money really goes in, is to make it possible to do all that instantaneously and optimizing costs. That takes a lot of thought and cost consideration. And so the subscription rates are really based on the efficiency that we can do in cloud infrastructure. Right, and then we also have the viewer. I'm going to show that all to you because I don't want to sit here and talk, but we have what we've also worked a lot on. One of the problems you have with browsers is that they're not incredibly fast. You will have noticed that when you zoom into your pictures, it takes a long time. So what we've done is a similar principle to what Google does. It's called tiling. So you notice probably when you go on Google Earth and you zoom in, that it's based on, I think it goes all the way up to 21 different levels in Google. Of course, we don't need that many, but depending on the resolution, we have what we call tiling levels in there. It's also possible to rotate the image in any direction. And we already have the main objects where you can You can just click on the object and it'll tell you the metadata. We still have to update quite a lot. That's work in progress. What we're also working on, which is really cool, is that for every single star that you have in your image, no matter how many there are, and that's also work in progress, you get the full spectral data for the stars. So you can find out, whether it's an O, B, a G star, or whatever star it is. You get the whole spectral analysis, which we are integrating in that. That makes it cool because you don't have to go into databases. You don't have to link all that. We're doing all that, right? And then you also have the possibility to toggle between normal and enhanced modes, compare what the image processing does, whether you like it or not. And then we have also the search possibility for your whole library. So you can basically search everything you have. So what we are hoping really to entice is that astrophotography becomes much more available to everyone to enjoy it. That's really the main key thing, that it eliminates all the manual slider processing, that you can concentrate more on having and enjoying your part, and that it really integrates into all kinds of different astrophotography workflows. It should definitely be beginner friendly. That's really important. At the same time, it should have enough power for professionals too, and it has to be future ready. So for whatever upgrades come in, as I explained, it will also always automatically update for you. Just before I'll jump over to the live demonstration, and I know I've been doing a lot of so what have we all got? We're quite a small group of very enthusiastic astrophotographers that are behind this. So the NINA integration is coming in April. We also want to do auto comet processing, because comet processing is one of the biggest pains there is. Think of all the gradient removals. We are thinking that we'll have a proper comet processing tool integrated into StarPx by the end of 2025. The biggest hurdle often is mosaics. As you know, mosaics is insanely difficult no matter which type of software you use. And we want to tackle that you can do huge tilings, and that's also by the end of 2025. So when you have a huge mosaic, and the distortions can be quite a lot. So there's a lot of maths involved in that in order to make that possible. But our aim is to deliver something that makes mosaic really simple, right? And most important, it should be more interactive, so give you a much more enhanced user experience, that instead of focusing on the engine, you focus on the real experience. And reduced focus on processing, as I said. Smartphone apps I talked about, annotation with star spectra is coming. Customizable storage for organizations, yes. Smart scope integration is also coming up, and if you're interested, we are launching in exactly 10 days. Now this time it's serious. I know I've disappointed the Astro Imaging channel before, and I announced we would go, but we had so many difficult hurdles to overcome that I had to postpone, or we had to postpone this by another few months. But this time we promise we're sticking it. We're sticking to our guns. So in 10 days, we'll be there. And also, I wanted to say, I'll be giving a talk at, Patrick already mentioned, that's NIF, April 5th or 6th. And if you are there on the 7th and 8th, I'm also giving a workshop there where you can test StarPx for free. And we'll be exhibiting there too. Okay, that's enough of that. And let's jump right in now. Let me just see if I'm on the correct screen. Give me a second. Yeah, let's see which screen it's supposed to be. Okay, let me just close this one because you don't need to see that. Can you see the screen now, by the way? I don't know if I'm...
Yes.
Good.
Seeing the browser screen now.
Thank you. I just want to be sure you're still there. Wait a minute. Let me just move this up here too, so it's not in the way. Okay, great. So this is the website starpx.com. So you don't see very much at the moment. There's nothing you can do at the moment. So I'm just going to quickly show you what it looks like. So at the moment, I'm in a developer mode here. So the usual way you would do is you can sign in with, wait, I just have to put my glasses on 1 second so I don't have, can see this a little bit better. Okay, so you can sign in here either with your Google account, or you can create an email or password. I'm just going to sign in here with my Google account. Have to wait a moment. And of course, you will initially get an empty gallery, right? Because I've been the main beta tester also. You see a lot of pictures, but that's more or less the, the type of view that you get. It's very, we try to keep everything really simple. You have your gallery there, and that's what you should focus on. And here are a few buttons. I'm just going to go quickly through the environment here, and then we'll get into the nitty-gritty fun part, or where we're going to really develop some pictures in real time. So you can select your favorite images here if you want to. This is really cool. You can remove the stars instantaneously from all pictures. Okay, you see that it's all washed out. I've removed completely all the stars, so that's how good this thing works. So if you want to see what all of them look without star mask, you get that because it gives you much more information about the object and the velocity that you want. You can change the layout here if you want to, into different formats. You can filter and so on. So that's the main thing. Just very quickly going here into, I'll get into the different subscription rates later, because I'm sure you're wondering, well, how much does this cost? And I understand that, and I'll get into that. But one thing is, you have your API key there. I was talking a lot about the API integration. We put a lot of work into that. So you just copy your API key and you just put it into Dropbox. Here's a Dropbox link. You see, if I press on it here, you can see I'm now connected to my own personal Dropbox. It's very easy to do that. So it just gives you a lot of possibilities. In addition, you don't have to have your own Dropbox. You can also use our storage, right? Okay, that's the main environment. And so let's just get going. So the main thing that you need to have here is add photos. Now, add photos is really add images. A window pops up and all you do is click on here. So you have two possibilities here. The one is you can upload single files, or you can just go folders, and folders include subfolders too. So that's the easiest. I'm going to start up just with single files so you can see how this is done. So I have here on the desktop, I have for tonight to put something together, I have a large folder called Astro StarPx. So I'm going to put that on, and I've got 12 objects here, which we can work through just for fun and see how all that goes. Okay, so if I click here, let's click on Andromeda. These are images captured by my friend Edmund, who's also maybe he's here tonight, but he kindly gave me these images. He is on the east coast of the US, and he took this with a Celestron. They are not calibrated images, by the way, and I'm just going to load this whole stack. This is taken with a color camera. It's this, I think it's a ZWO 6200 color camera. You just see upload. That's all you do. They come in here, and then I just click upload. Now watch. So important in this case is that you have a fast internet. You can see how in real time in parallel, all these images are being uploaded. Now, I've got very fast internet. I have to say that. It is a big advantage. If you have slower internet, it will work, but you just have to have a bit more patience. So let's just wait until all this uploads. So there we go. Got about a minute or so left. And
Christian, while you're
yeah.
Uploading that,
yeah,
are these calibrated images,
no,
or are these raw
no,
images?
They're raw. They're raw. They're not calibrated.
So are you uploading calibration frames, or you're just doing it with your software?
There's no calibration. If you do want to calibrate, you can do that, but you'll have to do it your own traditional way. If you say, well, I wanted to calibrate, that's fine, but we have purposely omitted that step, okay, of calibration, okay? So these are really uncalibrated images. And the reason, let me just tell you a little bit more. When we were in the age of CCD cameras, the calibration was much more necessary than, the noise level I'm just going to talk whilst this goes. I'm just going to close this, and you can see it's now up in the cloud, and it's doing it's two basic processes. The one is the stacking, which is happening now. This is all real time, and the second one is the enhancement. So I'm just going to let this run and talk a bit. There you go. There's already the stacked image. Okay, it's there. And that's not yet enhanced. So I'm going to wait a bit whilst the second process starts. And so the reason really why we came to this conclusion is in the CCDs when we had the famous, the 16803 cameras and all that, which were great, but they had column defects and many others, and their calibration was incredibly important. You had cosmetic corrections and many other things. But now the CCD cameras are now so low in noise. And also what we found out is actually a lot of the flats, very often the flats are not really necessary unless you have incredible wide field distortions, you may still argue. But for most applications, you can actually use you can use software to correct that, right? So here we go. So the step number one is done, and here's step number two. So this is a color. This is a number of color. You see 26 frames from a ZWO 6200 or 2600. I mean, Edmund, if you're online, you can correct me. I don't remember which one it was, 2600 or 6200, one of those. And it's done, and it's done. So we're completed here, the process. And let me just click on this image now and show you what it looks like. So the first thing you'll see here is you can see where exactly your image was taken. You can also see the size, right? So you see the frame, the orientation, and everything. Here on the main window, you can already see several options, and we will probably improve these icons a little bit. So just tolerate this for now. But you can hide the tools. This here means that's the stretched image. Okay, that's the stretched image. This is the linear image. So that's the difference between the linear and the stretched. Now here you can see different options, but instead of doing that, let's just click on the image itself and take a look. So I talked about a little bit before of very fast tiling. You can see here is a tile level 2, and we can really zoom into the image, and we can zoom into quite a lot of depth, and we get it almost in real time. The details of this image. And as you can see, it also identifies the main stars in here. We're going to improve this so that it identifies all the stars, but I'm just going to click on one of them. If you click on it, you can see this is G144 and so on. It gives you the coordinates of the magnitude and so on, and we will add a lot more information here, but that's the type of interaction that makes this rather cool. And you can actually start exploring what what you're taking at night, right? So where it gets really cool is if you zoom in, and now watch this. I'm going to say show enhanced mask. Okay, so there you go. You can see that we have very carefully worked at the enhancement. So this is really important. If I toggle this on and off, you see that we're trying to maintain as many stars as possible, because the key thing here, and we worked a long time on it, and we're still optimizing it, is that you don't really lose detail by putting some deblurring or enhancement, whatever you want to call it. It's not sharpening, it's just really polishing up the image, taking away the noise and so on, without, and enhancing details in the image without destroying the image as such. Watch this difference. You see that? So this is how carefully we've worked on it. You can also remove the star mask just like that, right? So there's your star mask gone. And then if you want to know where my stars are, well, here's your mask. And you can see we're not completely there yet. So that's why we still need a few days for release, because in this case, there are some holes in the star mask. And I'm being very open and honest about this. So this is nothing to worry about. This is just something that we have to fix here. So you can see there are some stars missing here on the larger ones, but they are not missing on the smaller ones. You can also take the overlay off if you want to. You see that? So you can do that. What's also cool is you have a ruler here. right? So if I want to measure, tell me how many degrees is Andromeda, I can pull this across. Let's make it yellow. It's much better that way. So you can see it. It's not so easy to see, and we'll improve this, but you can see in degrees, I think this is about, if I see here, it's about 1.5 degrees or so. That, and so you can really get down and you can measure it in real scale what this is. What we're also working on is a proper grid. You can see again, this grid is only conceptual at this stage, but we're going to have a beautiful grid overlay so that you can see the actual, you know, where you know, you can go along the equatorials of right ascension or declination or whatever appeals to you, you know. So that's another thing. I'm just going to take the rulers away. And another thing we have here is then you have just a very primitive adjustment. So if you want to, you can actually increase the saturation, because that's, you may not like the way we're doing it. If you don't want to use any of your own software, you can do all that in here too, right? Yeah, and then the fun part is really the download. Let me just close this, wait a second. So you see here where the hamburger bar is, you have all the different options. So you have the stretched RGB image, right? So you have the RGB that's enhanced, you have it without stars, or you have the star mask, and you can then individually download each of these channels. Makes it really simple. You can download them in JPEG or in TIFF or in FITS format, right? So these are the three that we offer, depending on the resolution. So if you jump to more sophisticated software, you will understand where we are landing right now. So this is already in the end part where you can start processing your image, right? And that's really the fun part. Okay, so let's try another. Let's have some more fun and let's do some more. So I'm going to grab some more. Let's take some, let's try folder this time. So I want to show you how that works too. So let's try Centaurus A. That's fine. I'm just going to upload. So in this case, it just uploads all the folders. If you have subfolders in this with LRGB, you can do that too. It will grab all of them. So I'm doing that again. And it's doing this, of course, it's quite a fast network that I have here. So you can see how it is, you know, how this is done in all in parallel. And as soon as it's uploaded, there's a green tick mark. So that's all you really need to do. And then there's this clear button. You see that clear? So you can then clear the whole queue so you don't see it anymore. It's good to do that because otherwise you're always going to see the queue of the previous run. So I usually clear the queue afterwards. So let's just wait a moment.
Christian, just for comparison, how fast is your network? I'm sure some of us are thinking, well, we have a 1 gig connection.
Yes.
What do you have?
Oh, this is a gig. This is a gig, right?
A gig?
So this is quite fast. So this is typical. Of course, I mean you have it depends, of course, if your images are huge, right? If you take like a 102 megapixel camera, then you're going to take a long time, right? But I would say if you have a gig, you're doing fine. I would recommend a gig, but if you do half of that, it's still fine. But I think at 100 megapixels, megabit per second, you're going to manage, but it's going to take a lot longer. Does that help? Does that answer your questions, more or less?
Well, I'm asking it for the group that's watching online.
Yeah. Okay. No, go and just interrupt me, please. This is anyone who has questions, just tell me. Okay. So I
do, Christian. I do have a question.
Yeah. Go.
How did you? The software took care of any dust bunnies?
No, not yet. So we have,
Okay.
that's a good question. So we have not yet integrated dust donuts, right? So far it doesn't do that. But again, that's something that is fairly easy to solve, and it's on our to-do list. It's not the highest priority, but it will be done. Okay.
Can you handle the file format from PixInsight?
Yes, that's XISF. We can. Yes,
Yes.
limited support, but yes, we can. We can handle that. Yes.
So if we do pre-processing on our images and then upload them.
Yes.
And it'll handle 32 bits, obviously.
Oh yeah, of course, of course. Yeah.
So Christian, as we're watching this process, what you uploaded, this is completely from scratch, right? I mean, I know you've got a lot of things that you've already uploaded, but the data that you just put up now is something that it's never seen before, right? There's no caching or anything going on as far as
No.
This is as fast as it goes with brand
if
new data that it's never seen before, right?
if you wish, you can happily, and I really don't mind. You can send me a Dropbox link, and I will demonstrate it to you live. That this is real. This is as real as it gets. Okay, so absolutely yes. There's no caching here. Absolutely not. That would be terrible. No, I wouldn't even think of that. No. Okay, so here's Centauros A, and sometimes it does fail. I can give you an example. Craig, because we're not perfect. Of course, we're not perfect. Craig There's no Stocks, catching who has here. also been on this channel, a very good friend of mine, sent me, for example, an image set yesterday, and he said he had a problem with that, and that was this one. That was this one, the rosette, and it wouldn't turn into color. And we had a look at it, and we found out that our automatic filter detection was failing on his images, right? So we had to refine that. So we are always refining. We're not perfect, and that's also why we need as much data as possible. But having said that, we are solving this, and all this data comes from either from our own or from other testers or so. This right. So. Okay, so let's jump in. So this is Centauros. There you go. And again, the same thing. So you can see the main stars here. I'm just going to click on one. Wait a minute. Let's just click on this one. Here, I'm just going to copy this for fun. Okay, let's just copy this on my keyboard so that, if I were to search here, I'm just going to put this in now. Oh, it's copying everything now. Let me just delete all that. I don't need all that. It's probably loading. Yes, do you want to load this one there? You see, so it's found it. So that's what we call the reverse search. And let's just try that for fun in the whole library. Okay, so if I do this now, oh, no, did bad copying here. Wait a minute. Let's just do this. It's loading. Okay, so now it's going to search my library for all there. There you can see I've other ones from Centauros. This was cool with Craig Stocks. We were out in Utah, did a masterclass together, and you can see. No, this is not Craig Stocks. Sorry, this is not this. This is the. I don't know where this. Wait a minute. I don't remember where this was, but anyway, it does identify the. No, that's a southern sky. Sorry, this is southern sky, where Centauros A is, and so on. It does. It does. Okay, so let's jump back in. And yeah, here, where are we now? Did this actually solve everything yet? I'm not sure if it did, because it doesn't look at the moment to me like, oh no, it hasn't yet. It's not finished yet. As you can see, it's not finished yet because it hasn't got the enhanced solution yet. So it's not quite finished. You know what? In the meantime, let's just upload another one. By the way, you can upload in parallel if you want to. So if you want to run several instances at once, you can do that. So if I upload, let's take, oh, Comet Leonard is a fun one that we did in Australia. Watch this one. That's a fun one. Comet Leonard, let's let that one run. And whilst that's running, I'm going to show you something really cool. I'm going to run another instance here because it would usually block you from running another one in parallel, but I'm going to do it. So we're going to run a second instance, and you can open as many browser windows as you wish. Let's take the Pleiades in this case. Let's try that one. Okay, now that's running in parallel. As you can see, I've got two browser windows open. I got this one. Let me just pull this over to the other side. This one and that one. That one's finished, so I'm just going to flush that. And that is processing Comet Leonard now. And the other one is still uploading, and then you can just go on and on. You can run all these in parallel. There's Comet Leonard. So let's just wait a moment until let's just jump back here. Okay, let's just see what's going on here. Yeah, so this is step number 1 done, but it hasn't done the enhancement yet. Now, okay, this is, that's also Comet Leonard. It's just, you know why it's called its HD so-and-so? Because it doesn't recognize Comet Leonard as a comet. What it has done instead is it's identifying a major star in there and then naming it according to the star, right? It's giving, it just made a self-identification here, right? So let's just click on here and see how that worked out. Okay, so here you can see all the possibilities. Now, Comet Leonard was a very nice comet, as you can see. It's because we didn't have any shift of stars. You know, so what I'm talking about is you have the object movement, of course, and you have the the Earth rotation, right? And if they move relative to each other, you get streaks, which usually you do because you either focus on the comet or you focus on the stars. But in this case, because the comet was so prominent, you hardly had any movement in the stars. So this is not really a true example of something that we want to do in future, where you can separate the comet from the background properly and so on. So this is, how should I say, a very modest example. So if I just take the overlay away, and let's see how this works. Okay, so that's the enhancement, the enhanced one. Let me just see this. There you go. That's the enhanced one. If I switch this on and off, yeah, you can see the difference, right? So if we take the stars away, that's what it looks like. So interestingly enough, in this case, it's also taking the green halo a little bit away, which is not completely correct, of course. That's because we have a green correction in our algorithms to remove some of the green. So we have to do a bit more work here. But nevertheless, it does quite a clean separation, you know, of the stars. Yeah, here that's a good star mask and so on, right? So it did quite a neat job here. Okay, let's jump back here. See where we are now. Okay, now there your Pleiades. Let's see how far we've come here. I just have to take a look here. Let me just check. Yeah, that's the Pleiades. Both have been processed. So the Pleiades should also be complete now. So let's click on it. So there is your overlay and so on. So if I take the overlay off, and let's just zoom in a little bit to see more details here. So this is all happening in real time again without tiling. And by the way, I can rotate the image. Let's see if I can do this here. 1 second. Yeah, there you go. So you can rotate the image too. Again, this is not perfect yet, but it's getting there because it's a little bit it should be a little bit less sensitive. And so let's look at, you see there's quite a lot of noise in here. So let's just, let's remove that there. And you can see you get quite a neat background, right? So again, let's zoom in as much as we can. And you can see here, we're at level 4 now, at a zoom of 358%. So if I remove, you can see that how the stars are coming out quite nice without, you know, destroying too many of the stars. We really worked a lot on that. And again, we are not perfect, okay? We're definitely not perfect, but I think, you know, we've come a long way of, you know, of interpreting this. Are there any questions, by the way, or do you just want me to hammer away more and more images? I really don't care. What is the...
I don't see any questions online. You know, probably all of us are scratching our head trying to think of what questions to ask. But I guess an idea that occurred to me is your enhancement is very subjective. I mean, we probably spend a good bit of our time in what you call enhancement, and that covers a lot of processes and a lot of sins.
Right.
So what is your enhancement really doing?
Yes. Okay. So let me answer that question by taking a narrow band, right? Because well, the enhancement mainly well, the enhancement is mainly a noise removal tool. That's it. Noise removal with very gentle sharpening. That's it. However, having said that, brings up a very important point. So I want to show you something completely different. Okay, let's jump into a picture that I already have somewhere to make my point. If I have it somewhere, let me just see. No, I don't. I don't have it in here. I thought I did. Oh, here it is. Look at this. This is the Crab Nebula. It's very interesting. Okay, so answering that, what we call enhancement. So this color combination is what I would call very subjective, as you would say, right? So if I put on this enhancement here, right, you can say I like this or I don't like it at all. So what we do is that we have all the individual channels for you, so you can jump in at any stage you want. So this, for example, is the stacked H alpha, right? This is the stacked H alpha with enhancement. This is the, this is the one that is without any background. So you can take individual channels here in TIFF and you could combine them in whatever software you want. If you want to do it in PixInsight, fine. If you want to do it in Photoshop, it's fine. So you have all the possibilities to take these individual channels at whatever stage you wish. That's why we have so many options, right? So because we know that people have different tastes, right? And you can choose whatever level you want from that. You can combine SOH in any colors you wish, right? So here's the S2, for example, right? Again, you can have the stars removed if you like that. You can have the whole thing just stacked if you have it oh, sorry, this is just not, that was wrong. What I meant to show was the S2 here. Here, just the S2 with the stars in. So that is almost as good as it gets because it allows you to jump in at any level and combine it with any colors. You can remove the stars separately. You can combine them separately. I can, if you want to, I can do a quick jump into Photoshop and just show you, how we separate the stars from, from an image and combine them again. That's a classic method of doing it and so on. But does that sort of answer your question?
I'm not sure. I have to think about this.
Okay. Okay. Any other questions, or shall I just continue? Shall we try some more? Let's try some
Yeah,
more.
actually, Jim had a question I've been thinking about.
Mm-hmm.
So your initial pitch was to get away from high cost PC, but nothing in AWS/Azure is cheap. What do your costs look like, and how do those compare to a new PC?
Okay.
I
Well,
guess we're all interested in what this
the
costs.
price. What does it cost, right? So let's jump in there. Just 1 second. That's a good thing. Okay. So let's go to the pricing. So if you go to, let's go the monthly. So we have a base price of storage, and that's 200 gigabytes, and that's the amount that is allowed to be processed per month, of $9.99, and that includes a lot, right? That includes all the tools. So you can, in this case, you can do RGB, SOH, or HOO, but mono and singles you can only do in one channel. And the main reason is why there are restrictions on there is because of the incredible compute power and costs associated. So we have spent, I don't know how much time looking at and optimizing costs for processing, right? So this is the base model. The standard model, and that's at $19.99 per month, gives you some more storage and also the possibility, so you can do all that star masking and all that plate solving is part of it. And we're going to in future also offer 3x3 panel mosaic solving and so on. And the volume that we allow here is 1 terabyte per month of data, right? That's the volume that you can do on a $20 plan, right? That's your storage. But you can use as much Nina as you want to. We're going to, for example, if you upload a lot of through Nina, you can do that too, through the API key. You can have it processed. But if it exceeds that amount, then it will only be available for a few days because storage and processing time is very expensive also for us. And that's why we're running these type of optimizations. I mean, compare this to normal Google Drive costs or so, or Apple, and then you will see that we're actually quite competitive. Now, the real hit then is the Pro model, which we only offer on a yearly base. And that gives you 3 terabytes, and that also gives you dedicated processing speed. So your queue, whatever you have, will be prioritized and will be processed incredibly fast. Whilst the others, you can take, you'll come in a queue depending on how many users there are, because we have to optimize the whole thing. So that's basically the pricing models that we have. Okay. So let's see how far we've come. So I just put in the Trifid Nebula here, and that's also finished. It went quite fast. And again, you've got the overlay here, and you can remove it. You can zoom in to any level that you wish, and you can press the enhance if you like to. You can remove the stars from that, and you can rotate it, right? So you've got all these possibilities. Okay. I can load some more images, or are there any questions? Anything you would...
Did you say that you had an interface with a C-star?
No, we didn't say that yet. Not C-star. We would that has to be integrated into there, right? So that's something we have to probably discuss. What we said is we have it with Nina. Okay, that's what we said.
Can you talk a little bit more about that Nina integration? What that, are you developing a plugin for that, and how's that going to work?
Yes, that's correct. Okay, let me just get back to here. Sure. Let's go here. Okay, so the Nina integration is at the moment we are going to release our own downloadable special part for Nina to just accelerate the whole thing. So you'll be able to download it for free on the StarPx site and use it. And what it will allow you is you have to then use your API key to link Nina to StarPx. And once that's done, you know that, for example, inside Nina, you have different plate solving options. You probably know that, right? Astrometry.net and ASTAP and so on. There'll appear another option where you can use the plate solve directly from StarPx. That's number one. And the second is that as long as you're connected to the internet, which is very usual nowadays when you capture images, is that your images are going to be uploaded straight to StarPx, just like we did now. And when you have a completed command from Nina where your image sequence has started or has ended, then as soon as it's ended, it will start processing your images, will stack them, and do all the fun stuff that StarPx does. Okay, that's what we're going to do, and you can upload as many as you wish to.
So that'll be I guess an automated process as you're imaging through the night with Nina. It'll be uploading into images in the background up to StarPx, and then it'll stack them all at the end of the night. That's what you're saying?
That's exactly what I'm saying. Yes, that's exactly what I'm saying. So it makes it really simple, right? And if you've linked it to Dropbox, it'll be in your Dropbox account, right? Yes. Okay, any other questions?
Christian, can you link it to a shared local drive like a NAS?
I don't know. I don't know at the moment. I think at the moment we don't have that. At the moment, the option is, because we're cloud-based, is that we are doing this through Dropbox. So you would have to organize that yourself in that case, right?
Right, well, it doesn't look like we have any other questions.
Okay.
Did you have anything else in particular that you had planned to show? Or I mean,
No,
it's really interesting to watch these images. I'm sure we could see a number of them, but
I mean, I could go on if you
here
want.
all night
Yeah.
either.
Yeah,
So.
let's do one. Let's do one more just quickly. You choose which one you want. I really don't care. I mean, I've got the Lagoon, I've got the Vela. What else is here? M83. The Helix takes a bit longer. That's a big one. That's a lot. That's 11 gigabytes. I've got the Duck Nebula. Any preference? And what? I mean, I really don't care. It's just I put some in. Do you have anything you would like to see?
Well, you could throw the Carina Nebula in there.
Okay, sure. Okay, let's do
And we
that.
did have a question come in.
Yep.
While we were talking here.
Okay.
Folks, be sure to get your questions in.
Okay, go.
What's the question? Indiana Bridges wants to know, when all is said and done and everything's finished, what remains stored on the StarPx drives following the processing?
Oh, that's a great question. And actually,
Indiana asks good questions. So
yeah, thanks a lot, because I should actually, one second. Let me go into the apps here. So this is my own Dropbox account, right? So this is very simple. So I have starpx.com. This is what we just been doing, by the way, live. You see, this is a Trifid, the Pleiades. So it's just, so as you can see, this is not, I'm not caching anything. This is happening live here with the date. So it's updating my Dropbox as we come. So these are all the images I've had in the past. And for example, let's click on a more complex one. Yeah, let's try this one. So you have a lot of things there. Look at all this. This is your storage. You have the stretched HA, O3, LRGB, S2, SHO, HOO, starless, all the starless options, the star masks for all this, the stretched. So it gives you huge variety that comes out of this. But not only that, excuse me, not only that, but at the end, all your images are then sorted by filter. Okay, so here you go. Here, all my blues are then stored also and nicely sorted. So if you've got a lot of mixed up data, it's going to sort all the data that you have into proper filter folders for later. So this is the original data that was on there. It's only nicely sorted now, right? So as you can see, you get quite a lot of variety there, right? In this case is a full LRGB SOH palette, right? And each of these can be downloaded, and yeah, we process from any stage that you like. You can have the linear one, you can have the stretched one, all the possibilities, right?
So now this is all stored. This is your Dropbox account, is that right?
Yes.
So essentially your storage on that is limited, I guess, by whatever Dropbox plan you might have. If you,
that's correct.
But
yes.
Is StarPx then saving anything like of any individual's data, or does it all get put into this Dropbox type situation?
Okay, so just maybe I didn't make that clear enough. Let me just go back to the let me just go back here to the pricing. Okay, so you have the option, not in the basic plan, but you have the option. Let me just go to monthly again. So here, the volume and also the storage that you have if you don't have a Dropbox account is 1 terabyte, right? So that's the amount that we can have for you. On the Pro plan, we can give you 3 terabytes of total and if it gets full, you will have to empty it yourself, right? So that's the thing without Dropbox. You can also link your own Dropbox, but the Dropbox can be as large as you want. Does that make sense?
Yes.
Okay, so that's what we provide. So we provide this in-house. That's a storage we provide, which is also equivalent to the volume per month. And there's also the image resolution that is allowed. So on the Pro plan, you can take any image resolution. So what that basically means is, if you've got let's say you have a 60 megapixel image, it will be resampled to 50 megapixels, right? And so on. That's the image resolution that you will get out of the out of the whole process.
That's the resulting resolution, not what you can upload. So
that's the resulting resolution. That's correct.
Okay.
Up to that. Yes. Yes.
So if you have a Dropbox account, you're not storing it on your servers. You're storing it on the Dropbox account.
That's correct. As soon as you link it, that's what I'm doing at the moment. Okay. So in this case, where was I? Sorry, 1 second. Got so many screens open here. Let me just see. Where was I? 1 second. Oh, where was my Dropbox? No, wait a second. Here, no, it wasn't this one. Sorry, got too many screens open. Let me just check here. So this is stored on my own Dropbox, right? It's under apps. Here you can see all files, right? And then it's under apps. This is my own because I've linked with an API key. I know it's been quite a lot, but I linked with an API key my own Dropbox to StarPx, right? Which gives me a lot of advantages because, I can handle my own data that way. If you don't want to do that, you'll have exactly the same folder structure, but you will have it under a StarPx cloud storage, okay?
So if you use the API and link it to a Dropbox account, you're not storing it on your servers.
Correct. It's only either or. That's correct. We cannot do both, right? That's correct. Yes. And also when you delete, when you go into your library and you delete something, oh wait, that's not what I wanted to show. Sorry, if you delete an object, let me just clear all this. Wait a minute. Let me just refresh this. 1 second. Now there's Etta Karina, by the way. There you go. That's the Etta Karina that came out. Overlay off, and there you go. That's the Etta Karina result. And so, yes, if you, sorry, what was I going to say about Dropbox? So if I delete this here, you see it also shows you how much storage you're using, right, in total for this. If I delete this, it will also be deleted either from my Dropbox account or from my, the whole thing will be deleted. Now, the interesting thing is also when we have updates, because I said before that when we have updates, which is quite important. Wait, let me just go to somewhere we had that. Let me just see where it was. There is somewhere a button, and I can't find it at the moment. Just give me a second. That shows you, and I don't know where it is at the moment. Anyway, it doesn't matter. There is an update button. So when we have newer software, you just press that update, and all your images will be updated with the newest software. But not only that, but the old version will also be kept for you. So if you don't like the updates for whatever reason, you can still keep the version. So that's why they all have a certain date on it, so that you have all the different versions, whatever you prefer. Okay, let me just stop sharing, and I hope that wasn't too overwhelming, but anyway, here we are. Okay.
Oh, that was great. Yeah, that really impressive, Christian. So it's clear that you all have put a ton of work into this, and as you noted, there's obviously a number of things that you're still tweaking and whatever, but I can't even imagine how much effort has gone into this so far. So, and there were some comments, and I certainly too was amazed by how quickly the processing happened in the background. So I guess that really speaks to the value of the cloud-based processing when, I mean, you may have a fast machine at home, but clearly the machines that you have at your disposal are real powerful. So.
Yeah, they're a lot faster than a 4090 RTX that you have, if you have a fast GPU. It completely outperforms that. So it does, but it gets really quickly very expensive when you invest in hardware. We forget that because it's our hobby, so the hundreds just fly here and there. But and we pretend to our wives or whoever that it doesn't cost anything. But in the meantime, the bills do extend.
So are you running your own servers? You're not using Microsoft?
No. We are running cloud-based servers. If you ran your own, this would explode the costs, and I know it sounds crazy, but it's complicated. Cloud-based stuff is very competitive, complicated. It changes all the time. You have to be so careful with robustness, reliability, and many other factors, right? It's unfortunately, it's an old project management of its own. So no, we are really running this cloud-based, right? And we've done a lot of research. Probably most of research goes into how to structure this.
Well, it's all really exciting, and I mean, the thing with the processing, obviously, it can be fun to process your own images, and but it's also work, and certainly, learning what to do, and so it's kind of the holy grail to have something that would automate a lot of that, or at least automate a bulk of it, and then you can do the final polishing at the end. So. And this is the first version that you guys have, so, and it's already this advanced, so it'll be really interesting to see where this goes over the next months and years. So.
Yeah, Patrick, what we're really aiming at is also the education. I'm very interested in education. So if you have these type of cloud-based tools that are so searchable, you can make this so exciting for the community, saying, well, how many galaxies do I actually have in that image, right? And what do we actually know? And how many undetected objects do I have, right? And how much, what's the distribution of all the stars in the image, and so on and so on. These are questions. If you did this in data science, this would be killing usually, right? Those are tough questions, right? And we think that we can tackle all this. This is still on our line, but that's what makes us so excited is the outreach and the education, the citizen science that is possible through that, right?
Yeah.
It's the exploration, right?
Well, it looks like we did get another question. Do you need to keep the original raw files in Dropbox after processing? with the processed images remaining available within StarPx?
No, so if you upload your own, you can delete your own because they are resorted under the the name. And by the way, I also forgot to say that we're going to have customizable, because people have their own ways of sorting their libraries. So if you don't like the way we're doing it with date and whatever, we're going to make customizable, just like in Nina, where you can customize your file name, right? Many people have their own preference. So we're going to do the same. That's also work in progress. So the answer is, you will have your own folders. You don't need to keep your original set. That's going to be stored under in StarPx itself. I'm sorry if that went too fast, but that's what I was trying to show, right? That all your images are kept in the original format. Yes.
All right, that makes sense. Well, and that's just the nice thing about having these live talks, and then, if you're trying to cover a whole lot of information, and if somebody's not quite clear on something, then get clarification like we just did. So.
And if you happen to be at NEAF, pop by and you can bring your own images. That's the whole point, Talk about the question of cache, you'll see whether we cache or not. Go test yourself. Okay, so I have the real experience.
All right, great. Well, it looks like we got all the questions. So thank you so much for coming on, Christian. This has been really, really interesting and fun to watch. So
my pleasure, really, and thanks to everyone, and thanks for everyone to listen to this and to take your Sunday, or maybe, no, sorry, it's Melbourne, it's already Monday, but anyway, to take your time.
Yes,
and
for most,
after we end
Monday.
After we end the program, we kind of hang out if you'd like to.
Yes.
That's where we ask the real interesting questions.
Good. That's fine. Let's do it.
All right, great. Well, thanks again, Christian. So with that, we will take it out. We'll see everybody next week.
Bye. Thank you.
Bye-bye.
Bye.
Good life.